Here's another homework problem. You need to prove using the first principles that the differentiation of the square root x is equal to 1 over 2 times square root x. We must use the first principles for this problem. That means you cannot simply go ahead and use the differentiation of x raised to the nth power to obtain the answer for this problem. When you use the first principles, you can use the right-hand differentiability or the left-hand differentiability equation. I would like to go for the right-hand differentiability equation. Let me write down that equation real quick. This is d plus x equals x. This is equal to limit as delta x approaches to 0. On the numerator, you are going to have f of x plus delta x minus f of x, and on the denominator we have delta x, which means in order to apply first principles, I need to figure out a function f of x. That function always is the given function to differentiate. Therefore, I'm going to let f of x be square root x. Then in order to use our right-hand differentiability equation, the first principles equation, I need to write down f of x plus delta x as well. F of x plus delta x is going to be equal to, all I have to do is to replace this x by x plus delta x. Then I get square root x plus delta x. Now we can go ahead and substitute these two things in this equation for the right-hand differentiability. Then we get d plus at x equals x is equal to limit delta x approaches to 0. On the right-hand side, on the numerator, we will have x plus delta x, square root of that, minus square root x. In the denominator, we have a delta x. If we try the direct substitution for this problem, we can see that delta x equals 0 is the direct substitution, which makes this term equals square root x. That minus square root x, the numerator is going to be equal to 0. That has to be divided by another delta x, which is also equal to 0, which is 0 divided by 0 undefined. Therefore, we cannot do the direct substitution. We cannot do the direct substitution means we have to evaluate this limit using alternative methods. So when you have an irrational function like this, what can you do in order to evaluate this limit? Remember, we rationalize the irrational component, which means both top and bottom must be multiplied by the conjugate of the irrational part. So what's the conjugate of this irrational part? The conjugate of a minus b is equal to a plus b. So the conjugate of this irrational part is square root x plus delta x plus square root x, close parenthesis. I need to write down that same term in the denominator as well, square root x plus delta x plus square root x. That way I didn't change the question given. Writing down this term in both numerator and denominator is just like multiplying that given problem by 1. If you need more help on evaluating irrational limits, there's a separate video explaining all the details of that. I'll have the link posted down below in the description. Let me now go ahead and simplify this problem. This is equal to limit delta x approaches to 0. On the numerator, how do you simplify that? We have it like a minus b times a plus b, which is equal to a squared minus b squared, with a equals square root x plus delta x and b equals square root x. Then when we say a squared, it is square root x plus delta x squared, which becomes x plus delta x. That minus b squared, b is equal to square root x. Therefore, b squared should be square root x squared, which is just x. In the bottom, I have this delta x term, and also I have all of this term. Therefore, I will write delta x times square root x plus delta x plus square root x. Now we can do some further simplifications. As you can see from the numerator, we have an x here and we have a minus x here. Those two will become 0 on the numerator. Therefore, this is equal to limit as delta x approaches to 0. On the numerator, we have just a delta x. In the bottom, I will have another delta x times square root x plus delta x plus square root x. Now we can do some further simplifications. The delta x's can be simplified. They can be divided from both top and bottom. That is because delta x is not equal to 0. Delta x is only approaching to 0. Therefore, that division is allowed. Now we can do the direct substitution. If you do the direct substitution, which means we need to put delta x equals 0. That direct substitution leads you to 1 over, the first term is just square root x when delta x is equal to 0, and then there's another square root x term. Those two will be simplified to become 2 square root x. So that's a problem we need to solve. I hope you understood what I did here. If you have any more questions, please feel free to let me know. Thank you so much.